Hey guys, so today we're going to start off with 4.3, which is Properties of Logarithms. We're going to start with three rules. So we have product, quotient, and power rule. The product rule deals with multiplication, so if you're multiplying, it actually can be separated into addition. If you're dividing, it can be separated into subtraction. And then the power rule, if you have an exponent raised to a power, you can actually, or if you have, sorry, if it's raised to a power, you can actually bring that power out front and multiply it by your log. So these are the first three rules that we're going to use. Let's start with the product rule. So what this is saying is if you saw 77, you could write it as 7 times 11. And you could break this up, you could expand, so they're going to tell you to expand. You could expand it into log base 6 of 7, and multiplication expands with addition, log base 6 of 11. Same thing here, we have 100 times x, log, our base is 10 technically. Remember, if we don't have a base, our base is 10. So log of 100, again, multiplication is addition, so log of x. Now, why would you want to expand? Why would you want to expand? Here, it doesn't really help us much. But here, it actually simplifies for us. So if you look at this first one, log of 100, again, remember how you read this from yesterday, 10 to what power gets me 100? The log of 100 is 2, because 10 squared gets me 100. So it actually helped us simplify. So why would you want to expand? Because sometimes it does help you simplify. And make the problem a little bit easier. All right, quotient rule. Quotient rule deals with division. And again, they're telling us to expand. So we want to take something that's in 1 and we want to expand it out. So we have log base 8 of 23. And the way you expand division is subtraction, log base 8 of x. Again, this one doesn't really help me much. Here we have a natural log. Remember, your base is e. So natural log of e to the 5th minus natural log of 11. Again, sometimes it can help you. So remember, your base is e for a natural log. E to what power gets me e to the 5th? Well, e to the 5th power. E to what power gets me e to the 5th? The answer is 5. Minus the natural log of 11. I know that looks weird, but that's the natural log of 11. So it does help us simplify a little bit. So why would you want to do this if it helps you simplify? The power rule, again, they're telling us to expand. So see that 3 to the 9th? You can actually take that 9 and bring it out front. So we can write this as 9 log base 6 of 3. Moving on. This might not look like a power rule to you, but remember you can write this as x to the power over root, cube root. So again, you can bring that exponent out front, 1/3 the natural log of x. And that would be your answer. Here, bring that 2 out front, 2 log of x plus 4. So if you have an exponent, you can bring it out front. If you have an exponent, you can bring it out front. Now this just says use logarithmic properties. So instead of telling you which one to use to expand, you're going to be using a couple. All right, so let's go ahead and put this in an exponent form. So we have log base b, we have x to the 4th, and we have y to the 1/3. Right, that's a cube root. So right now I see multiplication. So I'm going to break it apart with addition. Log base b of x to the 4th plus log base b of y to the 1/3. So I broke apart my multiplication. Now I also see a power, so I'm going to bring it out front. So I have 4 log base b of x. And then again, 1/3, bring it out front, 1/3 log base b of y. And that's about all I can do. All right. Next one. I see a lot of stuff going on here. So again, square root of x, you could be written as x to the 1/2. All right, we like the exponents. So let's take this division and split it. So we got log base 5 of x to the 1/2. Division is subtraction, minus log base 5 of 25y cubed. Here I see that 1/2 can come out front, 1/2 log base 5 of x minus, now here I have 25 times y cubed, so I can actually break this apart into addition. Use your parentheses though, because stuff can get weird. Log base 5 of 25 plus, right, multiplication, log base 5 of y cubed. So we have 1/2 log base 5 of x. Log base 5 of 25. You can actually evaluate this. 5 to what power is 25? 5 squared is 25. So your answer should be 2. So we're going to say minus 2. And then again, minus, that exponent can come out front, 3 log base 5 of y. And that's about all that's going to simplify. Not the prettiest answer, but it works. So you can use these to expand. You can also work them in reverse to condense. So this says write it as a single logarithm. So I see addition. I join them back together with multiplication. So we have log of 25 times 4. So we have log of 100. Remember, if there's no base, your base is assumed to be 10. So 10 to what power gets me 100? 2. So that one, when you condensed it, you could actually simplify, right? In the beginning, I don't know, 10 to what power is 25? Right? 10 to what power is 4? I don't know. But when you condensed it back into one single logarithm, you could actually solve. So it works both ways. Sometimes when you expand it, some stuff simplifies for you. And sometimes when you condense it, some stuff simplifies for you. Here again, both base 10, but I see subtraction. So I'm going to join it back together with division. So log base 10 of 7x plus 6 divided by x. And it could be in parentheses or not. Either way is okay. That one didn't really help me simplify, but it did condense. They get a little more complicated sometimes. So we're just going to work them through one at a time. If I see something out front, remember it could be an exponent, so we could write this as natural log of x squared plus, again, this can be written as an exponent, natural log of x plus 5 to the 1/3. All right, I see addition, which makes me think multiplication. So we're going to have natural log x squared times, I'm going to write this as a cube root because this is power over root. This is a cube root. So the cube root of x plus 5. And as ugly as that looks, that actually is a good answer. Okay. So putting it back into one single logarithm. Here we've got log of x minus 3, and that was an exponent. All right, so we're going to put it squared minus log of x. So I kind of just do them one step at a time. Just take your time with them. Subtraction tells me division, so log of x minus 3 squared divided by x. And there's your answer. This next one's a doozy. So we're going to take it one step at a time. Let's put that exponent back, log base b of x to the 1/4. Put this exponent back, log base b of 5 squared. And we'll put this exponent back as well. Oops, log base b of y to the 10th. So here, let's see. We're going to do, how about we do the subtraction? So we'll change this to division real quick. So log base b of the 4th root of x over 5 squared is 25 minus log base b of y to the 10th. Again, subtraction means division, so we're dividing again. Log base b of 4th root of x over 25 divided by, this one looks pretty terrible, y to the 10th. Remember, keep, change, flip, so we have 4th root of x over 25, change to multiplication, and then 1 over y to the 10th, flip, keep, change, flip. So really what we have is log base b of the 4th root of x over 25 y to the 10th. That was a little bit of a doozy. A little bit of a doozy there. The last one you're going to use your calculator on. So this is called your change of base rules. When you look at this, 7 to what power is 2,506? I have no idea. So you might not be good with working with a base of 7, right? 7 to what power? I have no idea. So you can actually change this base to whatever you want. My advice is to change it to something on the calculator, like a log base 10 or a natural log, and that's what we're actually going to do on these. So this one wants you to use the common log, which is log base 10, and this one wants you to use the natural log. Either way, you should get the same answer. So it should be log whatever base you choose of x and log whatever base you choose of a, and you divide them. So we're going to type this in the calculator as log of 2,506 divided by log of 7. So we made them both a base 10 now. And when you type that into your calculator, which I did put on Google Classroom again, you should get 4.02. Somewhere about there, about 4.02. Now this one says do it with natural logs. So again, you get to choose your base. That's why it's called change of base. You could choose to have a base of e if you wanted to. You could use those natural logs. So natural log of 2,506 divided by natural log of 7, and you should get the same exact answer. You should still get about 4.02. So change of base lets you change it to a base that's more convenient for you. My advice is to change it to one that's on the calculator, either a base 10, a common log, or a natural log. All right, that's it, guys. Get your homework done.